All right, so for 3.1, we're doing quadratic functions and models. We're going to use completing the square to write polynomials. We're going to write them in standard form. So that's the first thing that we're going to do. And then I'm going to show you how to find the min and maximum using algebra, since we've already learned how to do that with our graphing calculator. So for your standard form, okay, this book calls standard form vertex form. And so in this textbook, when it says standard form, they really mean this form. Okay, f of x equals a times x minus h squared plus k. Okay, normally we think of standard form as the f of x equals ax squared plus bx plus c. Okay, so I really don't like that your book calls it that, but I did not get to write it. Okay, so the standard form is your vertex form here. Okay, and then the reason why we like to call this vertex form is because you can pick out the vertex right away. Do you guys remember what your vertex is? Yeah, yep, so it's HK. Okay, and it is the opposite because of that negative. Okay, so that negative there means that you do the opposite. Okay, the plus there, you're just going to have K. Okay, so it's also called your vertex form. Now, this A in front is a very important value. It determines a few things. Okay, so the value of A okay, if it is greater than 0, that means it's positive. Okay, then the graph opens upward. And then that is going to create a what? So the vertex, is that going to create a minimum or a maximum? Yeah, great. Do you guys think you can write the second case down? So if A is less than 0. Okay, so that means it's a negative value. Okay, then it opens downward. Okay, so if it opens upward, you have a min value. If it opens downward, you have a maximum.
What about side parabolas?
We aren't going to do those. We're going to focus on the quadratic form. The side parabolas are when you switch your x and your y. And those are with different conic sections. So we're not going to do that in this one. Okay, so in example 1, you are going to be given a quadratic function, and then you're going to express it in, like I said, what they call standard form. So anytime they say that, they mean, so you can see the vertex. Okay, and then we have to find its maximum or minimum value. Okay, so our equation is f of x equals x squared minus 8x plus 8. Okay, and we are going to use completing the square, and we're going to balance the equation. Okay, so there are multiple ways to do a problem like this. Because it's asking us, like our goal today is to be able to use completing the square with it. Okay, that's the way that I'm going to show you and require you to do that. So the first thing you want to do is you want to group the x terms together. Okay, so on one side of the equation, you're going to be grouping your x terms together. So I'm going to take this. Okay, and what you're going to do is you are going to complete the square with only these x terms. So when you're completing the square, you are making this value into a perfect square trinomial. So when you first learned about factoring, you guys did a lot of perfect square trinomials. Okay, now in order to do this, you have to make sure that a is equal to 1. Okay, so we're going to check that a is equal to 1. So your a value is 1. You can only do the completing the square if you have that, or you have to do another step. Okay, and then add your spaces in. And then we're going to fill in the spaces. Do you guys remember what the formula is? Yeah, good. Yeah. Okay, so this is the formula for your square, b over 2 squared. Okay, so let's see how that works. So if you do b over 2 squared, sorry, I'll give you a second to write that down. Okay, so your b value is -8. So if you cut that in half, -8 over 2 squared, remember I like to write mine like this. You can also just write it as the 16. And then the reason why this is a perfect square, isn't 16 a perfect square number? Square root. Okay, it's because you're going to be factoring it. If you were to factor this is going to be x minus 4 and x minus 4. Are you guys with me on that part? Okay, so if you factor that down, the way that we would write that is x minus 4 to the power of 2, because there's 2 of them multiplied together. Okay, are you guys with me? I'm just making sure I'm not going too fast. Okay. All right, so once you have done that, this is a little bit different. Before, when we did completing the square, what we would do is we would add something to opposite sides. And your rule with algebra is whatever you do to one side, you do to the other. But if you're working on the same side, do you guys know what we have to do? Because really, what I did here is I added 16. How can I balance that on this side of the equation? You have to subtract 16 now because you're on the same side. So you do the opposite. So whatever is here is the opposite of b over 2 squared. Okay, and again, that's on the same side. Okay, so like when we talk about balancing equations, sometimes it is easier to think of this as a weight, right? If you're adding 16 pounds to one side of the weight, okay, in order for it to balance, you have to take 16 pounds off, right? Okay, so that's why you're going to be doing the opposite if you're on the same side. Okay. All right, so 8 minus 16 is what? -8. So then your equation is f of x equals x minus 4 squared minus 8. Okay, so this is your equation in standard form using completing the square. Okay, and then all we have to do is identify the max and min. And again, this textbook has you write it in function notation. So that's how we're going to do it as well. Okay, so function notation is just going to be, remember how we normally write f of x? Okay, this is going to be f of h is equal to k. All right, so you just have to pick out your vertex. Okay, and if this is your vertex, this is going to be 4, negative 8. Okay, and then you are just going to write this as f of 4 equals negative 8. And then you have to tell me if it's a maximum or a minimum. Okay, so our a value is 1. If a is equal to 1, it's positive, so that causes a what? Minimum. So your final answer is just going to be this. F of 4 is equal to negative 8, and it's a minimum. Okay, now sometimes when they give you these problems, they are not going to give you the equation in standard form. Okay, so the first thing I want you to do here is I want you to write this in standard form. And then you can group those two values together. Okay, so once you put that in the proper order, you group your x terms together, and you have to check to see if a is equal to 1. Okay, in this case, was your a value equal to 1? Nope. Okay, so it's going to be a very simple process to get it to be 1. We have to factor. Okay, so since your a value does not equal 1, you are going to factor out a from both x terms. And you're only doing the x terms because that's the only part you're using to complete the square. Okay, the only part you're using to complete the square are the x values. So that one works out quite nicely because what goes into both 3 and 6? 3. So you're only factoring out the 3. You're not factoring anything else out because you're going to be completing the square now. And then we're going to leave the plus 1 and then the plus blank. Okay, so we're taking something that we did before last year and now we're extending it a bit. Okay, so to complete your square, that step is going to stay the same, where you're still going to do half of b squared. So what's half of negative 2? Negative 1, so it's just going to be negative 1 squared. Okay, and this is where it's going to get a little different, so make sure you're with me. Okay, so negative 1 squared is 1. So if some of you put 1 there, that's great. You are not adding 1 here because you see how outside the parentheses now we have a number that's not 1. You have to distribute the 3 to the 1. So really, you didn't add 1, you added 3. Yeah, so I just did that part in my head with everybody. So like if you do negative 2 over 2, you'll get negative 1. So you can just cut that in half and then square it. Yep, so it would be your b over 2. That would give you negative 1, and then you'd square it. And if you are adding 3 here, that means here you're going to subtract 3. Okay, so really quickly, I'm just going to say one more time why it has to be the 3. It's because you're not adding 1 here. What you're really adding is the 3 times 1. And in order to balance the equation, whatever you add on one side, you have to take that away on the same side. Okay? Then you can factor. So when you factor, you're factoring x squared minus 2x plus 1. This is what you're factoring. I like to write mine like that because I like to just be able to drop that down. I like to not think about the factoring because I feel like I'm already thinking about enough things there. So I just drop that -1 down and then I add my like terms. So I have 1 minus 3, which is going to give me -2. And this is going to be your equation in standard form. And then it's asking you for the max or min. Okay, so anytime your A value is positive, okay, if A is positive, that is when it creates the minimum. Okay, so this is going to be a minimum. You can always just look at this value. If there's no value outside, it's a 1, so it's positive. Now it's a 3, so we have a minimum. And then do you guys want to try to write that in function notation? So it should be f of h equals k. So see if you can plug that in. F of h equals k. So it doesn't disappear, it's just rewritten in a different format. So like when you do the distributive property, it's kind of like that. How it doesn't disappear, it's just we're rewriting it. Or like if that was a 2, that's a little bit better, and you can't see it anymore. So what we're doing, you're talking about this 3, right? Yep, so what we're doing here is we're balancing the equation. So this is really a 3 when you distribute, so we're going to take that away.
Well, I'm saying why when you factored it before the x minus 1 squared.
Oh yeah, sorry. So the 3 is still there. The 3 is still on the outside.
So I'm confused because you multiply the 1 by the 3, but then when you go to factor it, you see that as a 1.
So it's because I wrote that down there to show you. It's like this. So if you have this, the 3, the x squared minus the 2x plus your blank, plus 1 plus your blank. Okay, when you're filling in this, it's the -2 over 2 squared, -1 squared, which is a 1. So your 1 is here. The 3 is going to stay, and then what you do is you factor this. So this is the x minus 1 times the x minus 1. So this becomes squared. The only reason I put the plus 3 on there is to show that you didn't just add a 1 because of the parentheses. You added a quantity that was 3, and that's why you have to put -3 there instead of the -1. Does seeing it like this help, like with the factoring? Okay, and then your vertex is 1, -2. So when you're plugging that in, you're going to have f of 1 equals -2. Okay, that's your function notation. Okay, so then for C, we're going to try one with a negative. Okay, so we're going to do something similar where you're going to group those first 2 terms together. And then once you group those first 2 terms together, you should be asking yourself, is your A value 1? And if your A value is not 1, then we're going to be factoring it out. Okay, so because the a value is not 1, your a value is -1, you are going to factor out a -1, which is x squared minus 2x, and then you can put your blank spaces in there. Okay, and you can fill in that blank space how you want. I'll give you a minute to do that. You're just coming in, just jump in with us on TV, okay? Okay, so if we do half of b and you square it, okay, half of -2 is -1, -1 squared is 1, okay, but really what you're adding is -1 times 1, which is -1. So if you're subtracting -1, what do you have to do here? Add 1. These two things should always be opposites. Okay, I'm a very visual person, which is why I like to write that part out. So I can see that those two are opposites because they're on the same side of the equation. Okay, you're somebody that might like to do the distributive property in your head, and that is fine too. And then you're going to factor. So when you factor this, -1 plus 1 is actually just what? 0. So -1 plus 1 is 0. So you can leave your final answer like this. Okay, and then I want you to say if it's a max or a min. And then write that in function notation. Okay, and if you're somebody that doesn't like to write it out like that, that is fine too. Okay, you can always factor these down into the x minus 1 squared, and then whatever you are deciding to add here has to be the opposite of this quantity, but you have to make sure that you distribute. So -1 times 1 is -1. So if you are subtracting 1, okay, then you have to add 1 to make the equation balanced or equal to 0 there. Now, this just happens to be -1, so you're adding those two terms together. You don't have to write the plus 0, you can just keep it like this. And then because your a value is -1, you should have written that this is a maximum. And you should have f of 1 is equal to 0. So your vertex is your h and your k. And in your standard form, I'm having them write out their vertex first. And then it's always your f of h is equal to your k. H and k. Yeah. All right, and then we're going to do the max and the min of the next function. Okay, and what I want you to do is to rewrite that in standard form. Just rewrite it next to it. We'll just say rewrite. We'll just have you rewrite it. Okay, so Morgan, when you're rewriting in standard form, what did you put first? Good. Okay. All right, now the next thing we have to do is find the x-coordinate of the vertex. Do you guys remember how to do that?
Oh, yeah.
X equals x-coordinate of the vertex. I know you did it last year because I actually just went over it with my algebra too. X equals something. No more. X-coordinate of the vertex.
Squared plus b squared.
No. Why do you don't remember that?
Y 2 minus
So the
y
x-coordinate? No.
y equals mx plus b.
These are all beautiful equations. But the opposite of b over 2a
I knew that equation, but I didn't know what.
was 4. Yeah, so it's the x-coordinate of the vertex, and you also use it to find your axis of symmetry. Okay, so your a value and your b value, you can pick out when this is in your standard form, your ax squared plus bx plus c equals 0. Okay, so your a value is always in front of x squared, so that's going to be -7. Your b value is in front of the single term, so -49. Now, notice when I said this, I didn't say negative b. I always say the opposite of b, so that when you're doing this, you don't have to worry about a double negative. If you just say the opposite of b, then you know it's 49 over 2 times a. Okay, so then you have 49 over -14, and then we're going to reduce. What's a number we know goes into 49 and 14?
7.
Yep, so we're going to divide by 7, so we get, you can put the negative in front, 7 over 2, and we're going to leave it just like that. Okay, now to find your max or min value, your max or min is the y-coordinate. Okay, so when you're finding your max or min value, you're going to be finding the y-coordinate. We are going to be writing it in function form. Okay, and so we're going to be doing this without our calculator so that we can remember some fraction rules today. Woo woo, fractions. So we're just going to substitute this into the original. All right, and then when you guys get to AP Calc next year, there's whoa. That's not true. Some of you are going to be doing that, and the reason why we practice that a lot is because there is a calculator portion and a no calculator portion. Well, yeah, what do you think we're prepping for?
Yep.
Nope. Okay, so these are all just very small things that you've done in your past. So when you're squaring something, okay, you are going to square the top and square the bottom. So you have 49 over 4. So this rule is one that I feel like most people need to be reminded of. Whenever you have a fraction and a whole number, what part do you multiply by? Yep, the top by the whole number. Okay, so we're going to do 49 times 7. Now, if you're doing 49 times 7 in your head, do you guys think it's easier to do 40 times 7 and then 9 times 7 and add them together?
I think so.
Okay, yep, you can just write it out too. Yep, so 40 times 7 is going to be 280. 9 times 7 is 63. And so you can just add those together. You're going to get 8 plus 6 is going to be 14.
I found out that.
No, it will. It will always work. You do it correctly, it'll always work. And then look, we just have the same thing here. Okay, so when you're multiplying, you have -343 over 4. But be careful, those aren't going to cancel out because you don't have the same denominator. To make something with the same denominator, if this is 4, what would I do to 2 to get to 4? Times by 2. So if I times by 2 here, I'm going to times by 2 here. Okay, so you get 686. Okay, and then if you want, you could really make that over 100 as well. Okay, so you could do 400 over 4. Now, if you're doing that, then what you would do is add these together first. Because look, this is just half of it. So then you just have to add 343 plus 400. What's that? Yep, so just be 743 over 4. That'll be the final part of it. Okay, so then what we're going to do is we are going to write whether it is a max or a min. To do that, again, you look at your A value. So your A value is -7, which means it opens down. So we have a max. Okay, so it's going to be a maximum. And then you're going to write it in function notation. So when you're doing the function notation, it's just your f of x equals your y. You can think of it like that. It's still your h and your k. So your x value that you found is -7 over 2. And that's equal to 743 over 4. Okay, and so that's going to be your final answer.
That's what I was thinking.
The whole time you were thinking? Move it this way. Yeah. Yeah.
Well, I have a question, but you might say it's a question.
I would not say that. So, the only bad questions are the ones I just answered out loud. So as long as I didn't just say it, you're good.
Times it by 2 to get the common denominator.
Yeah.
What if instead we decided to square it because it's the
So you can't do that because it's not mathematically legal. The only way you could square something is if you square it on both sides. So the reason why you are able to do it like this and only this is because you're multiplying by 2 over 2. And what's that equal to? 1. Yep. And whenever you multiply something by 1, it doesn't change the value. But if you square it, it does. Yeah. And that's actually something common that we talk about, right? It has to be equal to 1 because some students do try to square it that way. So. Okay, and then, all right, for B, do you guys want to try that on your own?
Yes, please.
Okay, let's do it. Okay, so you're gonna use the same formula, the opposite of B over 2A. Okay, make sure that you got the x value correct, the -2. Okay, and then you're going to plug that in to find the other one. And then I'll look around, so if you're not sure how to start it, you can tell me. Okay. Hey, when you guys plug that in, make sure you follow your order of operations. So do exponents first, then multiply, because that's something common that people miss sometimes. Okay, so if you're plugging in h of -2, okay, so what's -2 squared? 4. What's half of 4? 2 minus 4 minus 6, so minus 10. Right? So look, I believe that you can do this faster without your calculator. Okay? Okay, and then again, you just have to tell me if it's a max or a min. So your A value is 1/2. So is that going to be a max or a min? If it's positive, it's a min. Okay, so it's a minimum, and then you're just going to write this in function notation. So function notation is f of your x is equal to your y. So the vertex is a point, right? So any point is x, y. They just have designated the vertex as h and k in different equations, but they really are the same thing. Okay. All right, and then the last one, we are going to do one of them from your textbook. So what we're going to do is we're going to read over it together, and then I'm going to, well, we are all going to just write out not the entire question, but we're going to write out the question that we're trying to answer. Okay, and this is perfect for this time of year because it's an apple tree. Yeah, I know. So it's an apple tree. Okay, so the number of apples produced by each tree in an apple orchard depends on how densely the trees are planted. So if n trees are planted on an acre of land, then each tree produces 90 minus 9n apples. So the number of apples that's produced per acre is that equation, A of n equals n times 900 minus 9n. Okay, so you guys just take a moment and write that equation down. That A of n equals n times 900 minus 9n. All right, and then what we're trying to answer is this question. How many trees should be planted per acre to obtain the maximum yield of apples? How many trees should be planted per acre to obtain the maximum yield of apples? Okay, so we're going to write down that question, okay, on our sheet. That's the question that we're trying to solve. Okay, so how many trees should be planted per acre to yield the maximum amount of apples? How many trees should be planted per acre to yield the max amount of apples? Okay, and then remember, your equation that you guys wrote down was A of n equals n times 900 minus 9n. This is the number of apples produced per acre. So they're already giving that to us in terms of per acre, okay? That the 900 is just what they gave us. So they did the work and they gave us the equation and said that's their amount of apples that are yielded. So they gave that equation to represent the situation. So it says that we have to find the trees. So we have to know what your A value represents and what your N value represents. Okay, we know that the N is your input. We know that the A of N is the output. Okay, and they tell us that A of N is the number of apples produced. Okay, in the text, they also tell us what the value of N is. I'm just going to put it back up there to remind us. It says if N trees are planted on an acre of land. Okay, so N is going to be the amount of what? Trees. And what do we need to find? Trees. Okay, so we're going to find the trees. Okay, so your N value, if that's your input, is similar to what? Similar to what variable? Your X. So this is like your X, this is like your Y. Okay, so, and you can use your graphing calculator as well to find the max and the min. Okay, so this is something that you could find with your graphing calc. So you can use it for this. Yep, you could. Okay, the only thing with that is you might not be able to see it on your window. Okay, so if you plug that into your graphing calculator and it doesn't show on your window, it might not even say error. You just might not be able to see that. You can adjust your window. Okay, so let's practice that. Okay, now, and you can plug this in just like this on your graphing calculator. You could do X and then in parentheses 900 minus 9X. Okay, and then if you graph that in your 10 by 10 window, I see something, but I don't see any kind of curve. Okay, sometimes if you do zoom fit, it might do it, but sometimes it won't. Sometimes it gives you kind of like a funky window there. Let's see if this works. So see how it's giving you part of the curve? Okay, so what I do to help me get a better window is I find the X value with algebra, because you already know what your equation is, right? So if you know that your equation is N times 900 minus 9N. Okay, can you find your A and your B from that equation and find the center? Yeah, what would your A be? -9. The A value is always in front of the squared term. If you want to put it in standard form, you can. Okay, so then I want you to do the opposite of B over 2A. And think about how that's going to help you with your window. Okay, so once you find your X value, which is what did you guys get? 50. Okay, that lets you know what you want your X window to be, right? Because if you have a maximum value and you know that the vertex is at 50, what would be a good value to go to on your axis? Oh yeah, you said it. 100. Okay, and then the scale is just what you want it to go by. So you could go by 10s, you could go by 5s. Okay, and then your other value, you might not be able to see the top of it. So if you wanted to know what the Y is, you could also just plug that back in. So if you plug in 500, or not 500, sorry. You plug in 50, negative 9, 50 squared, plus 900 times 50. Okay, then you know that, okay, well, my max better be, gonna do 30,000. I know, let's make our scale by thousands then, so I can see it. I know, isn't that nice though? That's not the apple trees, that's the number of apples produced per acre. That's the number of apples. Okay, and then if you want, you can do your maximum, like where you do your left bound and you can do your right bound. Okay, so you could also find it this way to find your maximum value, and you'll see the 50 there. Okay, so how many trees should you plant? Which one is going to be your value of trees? No, that's the number of what? Yeah, so this is the trees, this is the apples. So the output is the apples. And just pay attention to what they're asking you, because sometimes they might be asking you for the y-coordinate. Okay, so you should plant 50 trees. Okay, do you have to find this with your graphing calculator? No, I would find it with algebra, but I know a lot of you like using that as well. Okay, all right, so on the homework problems, there are some that have like a part B, but you don't have to do that. Okay, so for these, don't do part B. So I just said no part B. And then the 34 through 40, that's you're using your algebra. And then the last ones are finding your max and your min.